Since you answered the other one. Close that today, because those of you who have course, they should be looking all confident there today. All right, can we look at some of what you have? If you haven't been able to do that in 10 minutes, odds are good you don't know what you're doing. All right, so if we look at question 1, do we remember the formula? For those of you who are like, I don't know today. Yes? All right, the question asks for heat. So since the question's asking you about heat, you should be using your formula. All right, Q equals M CP delta T. Now, the question asked you to find what? Q. It asked you to find Q. All right, you know this because the question said how much what? How much heat. Because it said how much heat, that is what tells you Q. If it said how much specific heat, it would be looking for CP, okay? Because this says grams, that tells you that's a mass because it says grams. And it says increased temperature by 35, tells you that's a what? Change of temperature. That's delta T. So we know mass is 15 grams. We know we're looking for Q. And we know the delta T increased by 35 degrees. Now, if you remember Friday, I told you delta T is always going to be the positive difference. So even if they give you 2 temperatures and you subtract, are you ever going to keep the negative sign? No. No, you're not. Now, we need a specific heat. They didn't give us a specific heat. So if we go back, what element did they give us? Iron. They gave us iron. So if you look on your orange sheet, what's the specific heat of iron? 0.449 if my memory works. Okay? Now, when you look at the top of the orange sheet, the unit listed at the top of the column is joules over grams degrees Celsius. Okay? So when you plug into your formula and you solve, Q is what we're looking for. Mass is 15.0, 0.449, and times 35. Now, when you take care of your units, the grams cancel out, the Celsius cancel out, so our answer is going to be left in joules. All right, so when I calculate here, 15 times 0.449 times 35, I get Q equals 235.725. Now, my significant digit rules. If I look, this had how many significant digits?
3.
This one had how many?
2.
That means my answer needs how many? 2. Okay? So when I round, what am I going to round it to? 240, or if you said 230, I can live with either answer. And what unit did we just say we were going to put on it? Joules. Okay, I can live with either one. Questions? If you don't round to significant digits on the quiz, All right, not today's, because today's is all about rounding to significant digits. But on future quizzes where you have to calculate, it's like units. It's a -1.
Students, good morning. This is just a reminder that we no longer are giving out clothes and jeans and tape for dress code. If you come to school in violation of the dress code, your choices are to sit in ISS until a parent comes. If that's all day, then you will receive your work in ISS all day. Also, teachers,
Bring my hall
if
pass
you are
back.
in need of an office desk, we have one in the main office. Ms. Hunt's desk with the hutch above it. Please notify the front office immediately. This desk will be moved this morning.
All right, so number 2. Let this be a lesson to me. The next time I send one of you out for dress code, you don't get to take the hall pass. All right, so what's the identity of the element? Did you have a note or anything, Jocelyn? Or are you just late? Did you come on a bus? Huh? I couldn't hear you. Dress coded? Okay. So, what's the identity? What are we going to have to find the identity? Very good, Michaela. So we need the specific heat. So if I go back and I just take out this right here and this right here, we can just use the general format. So what do I know in number 2? Okay, so 13.8 grams goes here. Okay. All right, Q is 856 joules. All right, and what do I do with the 2 temperatures? All right, so 96.4, subtract 35.7. Somebody tell me what we get when we do that. 60.7. All right, so we're looking for CP. So 856 is Q equals my mass, which is 13.8 CP and 60.7. Now, we did not do one of these on Friday. All right, so if you're sitting in math class and you need that CP or that X by itself, what do you have to do to get them?
Isolated.
Okay, so how can we do that? Okay, that's called combining like terms. They're on the same side. For those of you who forgot that language in math class, so 13.8 times 60.7 is 837.66. And you don't have to actually write this down. I'm just doing it for instructional purposes. Okay, so that gives us, we've isolated the variable, combined like terms, whatever you want to call it. All right, so we need CP, so now we're going to do what? We're going to divide 837.66. 837.66. CP is equal to 856 divided by 837.66. We get 1.02. Now, let's say you were solving for this and you just needed CP and you need the unit. Now, you have a joule, you have a gram, you have a degree Celsius. Are any of those units the same? So they're not going to cancel out, but you don't know how they go together. Look at the top of your specific heat column. You see the unit? Okay. If you forget the unit or don't know how to put it together, at the top of the column is the unit for you so that you can do that. Now, when it's time to write the number in significant digits, let's see if I rounded correctly, because I just arbitrarily chose 3. How many are here? How many are here? So fortunately, when I chose 3, I chose wisely. If I needed 2, I'd have needed to drop something. If I needed 4, I'd have needed to add something. But I needed 3, so we're good to go. Questions? See how I do that after every question to see if I have the right number of significant digits? You have to get in the habit of doing that too. All right, last question, number 3.
Wait, wasn't it asking
Yeah, Elena.
We always gonna set up our questions like that?
Yep. You don't have to show all of that work. I do it for instructional purposes. Oh, the identity. So 1.02 on the chart. What did you pick?
Yeah, I think I need them.
Is that the only one that had 1.02?
It has 1.03, but that's supposed to.
Then I'd pick magnesium too. That sounds right. Okay. So Kelvin to Celsius. So K equals C plus 273. 45 equals C plus 273. What's 45 minus 273? Sounded like you yawned. Minus 228. So negative 228. So negative 228 degrees Celsius. All right, and 31 Celsius to Fahrenheit. So 31 equals 5/9 F minus 32. So cross multiply, because again, I'm terrible at fractions. 31 times 9, that is not improved with age, equals 5 F minus 32. I'm not distributing this time. I'm going to divide by 5 on both sides. So 55.8 equals F minus 32. Add 32 to both sides. 87.8 equals F. So degrees Fahrenheit. And I only needed 2 significant digits, so I'm going to say it is 88. Questions?
Wait, so since you did would you just, I'm trying to figure out the significance digits part because you had a lot of numbers that you just did math with. So which one?
You only use the starting data.
Okay.
You only use what is given to you in the question. The formula is irrelevant. Does that help?
So if I were to before even starting the problem, I would have to know that my answer would have to have 2 significant digits because all the starting data has 2. Yeah. That's what I would.
Okay, theoretically, this one should even be rounded to negative 230 degrees Celsius. So it has 2. Because this one had 2. I just forgot. Because typically once we get to where we use temperatures regularly later in the semester, I usually stop dogging you guys about significant digits. Because by that point, you've got it, and I've stopped hounding you. I even stopped taking points off. Questions?
And then the only thing on our quiz today is going to be just adding and subtracting.
And multiplying and dividing with significant digits. Yep.
I also had a note in my binder, and it says, I forgot, it says, tell Ms. Wall to explain specific use.
Yep, don't forget. That's why I put that there. Because I will forget. All right. Anything else before we talk homework? Questions? Yes, Doug? All right. Let us see. Question number 1 on the homework. I'm going to call out the answers in 2 ways. I'm going to call out the answers before you rounded and after you rounded. Because some of you are going to think you've got it wrong possibly once we round. And the temperatures, I'm not even going to worry about rounding. All right, number 1, negative 59 degrees Celsius. 318 Kelvin. And negative 423 degrees Celsius. All right, 2 through 6, I'm going to round. Number 2, you should have 81.2. And you need to round to only 1 significant digit. So you should round it to 80 joules over grams degrees Celsius. That's for number 2. Number 3, you should have around 92.1. And again, you need 1 significant digit, so you should round it to 90 joules. Number 4, you should have 0.416, 0.41, somewhere in that ballpark, And you need one significant digit, so 0.4 joules over grams degrees Celsius. Number 5, you should have 10.7, and you could either round down to 10 with a decimal, or you can round to 11 because you need 2 significant digits, and the unit is joules. And number 6 is 1010, 1010 joules, and you can only have 2 significant digits. So the only way to do that is put it in scientific notation. So 1.0 times 10 to the third joules. It's the only way to get 2 significant digits there. All right, who has a question? Allie?
Number 2.
Yep. Did you just copy it all out of the text or out of this chart? Because I asked for the specific heat iron.
No.
Okay.
I
Okay. So you're supposed to use the numbers, even though it's a really weird number when you work it out. So your specific heat is what you're looking for. And even though I asked for iron, these are some seriously weird numbers. So you get Q is 6502. The mass is 4.0. You're looking for CP. And then your change in temperature is 0 to 20, so the change is 20. So 4 times 20 is 80, times CP equals 6502, and divide by 80 on both sides.
Oh, okay.
Okay? So when you get CP, you get an answer of 81.2. And because this one only has one significant digit, that's why you round to 80. All right, that's all hand Sumatra. Number 4. All right, number 4 says determine again the specific heat. So this heat in number 4 is 50 joules. The mass is 6. We're looking for CP, and delta T is 50 to 30, which is 20. So 6 times 20 is going to be 120, I think. And then you're going to divide by 120 on both sides. Let me make sure 6 times 20 is right. Yeah. All right, and 50 divided by that is going to be 0.41. Precious. Yes. Anybody else? Yes, ma'am. Number 5. All right, number 5 asks you to find the amount of heat. So you're looking for Q this time. So it gives you the mass is 2.8 grams. It tells you the specific heat is 0.384. Whoops. 0.384. And the temperature changes from 25 to 15. So when it changes from 25 to 15, all you have to do is subtract the 25 and the 15. So 25 minus 15 is what? 10. And always make sure it's a positive number. Never use the negative number, okay? And then you're just going to multiply all that out, and you get, not too bad, 10.7. And it'll be joules. Yes, ma'am. Yeah, because you get an answer of 1,010 when you calculate, and you only want 2 significant digits. So if you try to round that to, let's say, 1,000, 1,000 is how many significant digits? 1. Okay? Some people will round that up to like 1,100. But 1,100 is not really 1,010. Okay? So the easiest way to make it the same number is remember the decimals here. And you can make the calculator do it. Just put it in mode and psi. 1, 2, 3. So you get 1.0 times 10 to the third. But you can put it in scientific notation on the calculator, and the calculator will do the work. You don't have to move the decimal by hand. Okay? Anybody else? Question on the homework? Question on calculating? Zaria. Mm-hmm. Yep. Anybody else? Question? All right. In that case, let's do our quiz. Now, the quiz is divided into 2 sections. 7 questions are in normal or fixed decimal notation, and you have to do those 7 in fixed decimal. There are 3 in scientific notation, and you have to do those in scientific notation. This is the only time I will demand that those be done that way. Okay? After today, you can do them any way you want. But today, you have to do the first 7 in normal notation, and the last 3 have to be done in scientific notation, because I'm checking your knowledge of significant digits in a particular way. But after we do this quiz this way, you can do it any way you want. Okay? And after one of you guys finishes the quiz, let me know, because I'm sending one of you guys to see if my hall passes there. And if she's not 9 6, then I guess we'll send you to the office to see if we can find out where she went in the hall pass. Before you know, Mr. Howells had been killed. So I get to do that with that here. Do have some leverage. Couldn't go too far. Anybody know if Princess drives? She called her dad. So she's an ISS? Okay. The hall pass is retrievable. Thank you for keeping me abreast over there, Precious. All right, so everybody sees 1 through 7. The questions have to be answered in normal notation, just like those numbers are in. Everybody see that? And then 8, 9, and 10 have to be answered in scientific notation. Everybody got it? This is the only quiz that works that way. Every other quiz you can do any way you want. This one has to be this way. Then around your neck, go to ISS, get my hall pass. Good, you're still working. That's only two. All right, that's good.
He said that the principal is something back up there.
Said what?
He said the principal is bringing it back. The principal will bring it back.
Okay. All right. She didn't say which principal? Probably needs to be lost. Anybody still working besides Alan? All right. You go pass first. All right, find your notes. We're going to move on today. Matter of fact, if you want, you can put your calculators up because we're done with them for the day too. That way you don't knock them off your desk and hit the floor. Okay. All right. So we're going to move on, and we're going to talk about physical and chemical properties of physical and chemical change. Depending on what you had or who you had in middle school, some of what we are going to do today should be entirely reviewed. Physical and chemical change and properties are my curriculum. It goes with the topic we're going to study later. Theoretically, you had it in 8th grade. So it should build on what you've already had. Depending on your experience, some people tell me they've never seen it before in their lives. Hopefully that has not been your experience, but we'll just see. Now, before we do that, we're going to talk about 3 vocabulary words that everybody should have had in multiple science classes. Should not be unique to mine. Should not be unique to the middle school. You should have seen it before. Just label it physical and chemical change. Now, can somebody tell me what matter is? And has? Yes. Now, some teachers won't teach it as takes up space. Instead of saying takes up space, they will teach it as has mass and volume. It means the exact same thing, just depends on who you had and what definition they like better. Okay? I tend to teach it the way that Franco said. Anything that has mass and takes up space. Some teachers prefer to say anything that has mass and volume. It just depends on which one you prefer. All right? The meanings are identical. Now, the issue that students tend to have, is when I ask for examples. All right? If I was to ask you for examples of matter, students can do this one pretty easily. Give me some examples of matter. Okay, the desk, what did you say, Xavier? The what? Give me something else. Sure. Give me one more. Serenity, give me one more. Sure. Okay. So the challenge for most of us comes in when I ask for something that is not matter. Okay, sometimes I have students who nail this the first time out, and then I have groups who struggle with this. So let's see which category y'all fit into. All right, give me some examples of things that are not matter. Okay, we're going to fit in the other category. All right, air. Air is matter. Gases are matter. For example, I have new tires this weekend. All right, I was running around on my spare all of last week because somehow I managed to get a screw in my tires and they were pretty low on their tread. So when we took it to the tire shop, they're like, dude, nope, that one cannot be fixed. So I was not putting a new tire on a set that needed to be replaced anyways. So on Saturday when they put the new tires on my car, what they have to do to the tires? They had to put what in them? If we couldn't, air didn't take up mass and space, would my tires have inflated? No, they would not have inflated. So air is matter. Okay? if air was not matter or gases were not matter. In this case, what gas do we exhale? Carbon dioxide. Your biology teachers would be thrilled. Okay, could you blow a balloon? Mm-mm. What? Light. Light is not matter. Light has no mass, takes up no space. Give me another one. Yes. You didn't think there was just one?
Sound waves?
Yes.
Wait, really?
Sound does not matter. Heat.
Electricity.
I'll take it.
Oh, for real?
I will take it. It's not what I'm shooting for, but I will take it. What do you think I was shooting for that started with an E?
Energy.
That's what I was shooting for.
Oh.
All right. Now, the last two words that I wanted to talk about are words that we tend to use interchangeably that are really not interchangeable. Does everybody have what they need? All right. Which are mass and weight. Anybody remember what mass is? Anybody? It's the amount of something. The amount of matter in an object. Now, weight is different. Anybody know what weight is? This one people usually remember. Anybody? Huh? All right, it's based on gravity. Okay, this one's a measure of the gravitational on an object. Measure of the gravitational pull on an object. Now, a lot of times we'll say a measure of the Earth's gravitational pull on an object, because typically we're talking about the Earth. However, do we always have to talk about the Earth? No. Okay? So, when we talk about mass and weight, what's the difference between the two? What's the difference between mass and weight? You got to go. Y'all don't talk loud enough for me to hear that thing. All right, what's the difference between mass and weight? What'd you say, Franco?
Weight is based on gravity.
Okay, weight is based on gravity, but that's not the answer. Anybody else? So let's say, for example, why are those out of order? Whatever. All right, so let's say that we have the Earth. We travel off to the moon. All right. What's going to happen when we go to the moon? We're going to weigh less. Okay. So, I'm actually going to weigh 1/5. Yeah, I'm willing to go to the moon. All right, now, what happens if we go to Jupiter? What happens if we go to Jupiter? Anybody? What? Let's assume we can go to Jupiter. Okay, forget the Earth or the Earth science y'all learned about the planet. We can't go there and all that stuff. Let's assume we can go. We weigh more. Okay, why would we weigh more? Okay, why would we weigh more? It's a bigger planet. Okay, because it's a bigger planet, it has more gravity. All right, gravity is based on size. The moon is smaller, it has less gravity. Jupiter is bigger, it has more gravity. Okay? There's a principle called the universal law of gravity, gravitational pull. All right, you all exert gravity on every object in the room. Kayla, you and Precious are going to have to be separated.
Okay.
Okay? So somebody on this side of the room is going to have to give up their seat to Michaela or Precious. I'm leaning towards Precious over here and Gerardo over there.
Alright.
Will that work for you, Gerardo? Or you'll be all kinds of upset with me? Thank you for being very kind and understanding. It's a bigger desk. I think you'll like the desk. It's actually a plus-size person desk.
Wait, then I'll move it.
It has a bigger surface to write on also.
You're not plus size yet.
But I appreciate you being willing to move.
Bye.
Now, but every person exerts gravity on every object around them. Do you feel yourself pulling your pencil towards you?
No.
No. Do you feel yourself attracting the paper that you're writing on? No. Why? Do you have a lot of mass
Yes.
compared to something like the Earth, the Moon, or Jupiter?
No.
No. We're not massive enough to feel the gravitational pull on paper or a pencil or anything else. Precious, you want to charge in the back so that you're not playing on your phone. Now,
Come on.
how does mass compare to weight? All right, I put Elena in the same space shuttle and send her to the moon and to Jupiter. How does her mass change? Does it? No. Okay. Mass stays the same. Okay? It doesn't matter if Elena goes to the moon or Jupiter. Her mass does not change. Okay? She's going to weigh less, or she might weigh more, but her mass is not going to change. The only way that I can change Elena's mass is maybe to cut off an arm, cut off her leg. I'm not planning to do that, don't worry. Okay? So it doesn't change. Weight changes with location. Mass stays the same. Okay, that's the difference. Weight changes with location and mass stays the same. Everybody got it?
Yes.
All right, we caught up? Or do I need to wait? All right. let's talk about physical and chemical properties. All right, we're going to start with physical properties, and then we'll talk about change. All right, a physical property is a property that can be observed without altering the identity of a material. So I want to look at my desk that is up here in front of the room. I don't want you to tell me it has stuff on it. I know it's got stuff on it. Assuming it does not have the notebooks, the laptop, or the rulers or anything. Tell me some things about the desk that describe the desk. Okay. So the material that it's made of. Okay. What else? It's what? Use this one instead of that one. So what shape would this be? Okay. So we'll put shape. Okay. What else? Okay. Give me some descriptions to describe size that we've learned to measure in the last week. I'm not telling you to give me the measurement. How would we measure? What things have we learned to measure? Okay, length, width. What else? Height. Sure. What else can you tell me about the desk? Describe the desk if you were describing it to somebody across campus. Okay, we got those things. How else will you describe it as big? What else would say to you it's big? Mass. That's all y'all got for physical properties?
Color.
Sure. What's wrong with color? It's not round. We're doing this desk.
I said brown.
Brown?
You said color like
Oh, I don't want you to tell me the color, just a physical property. All right, what else? How does it feel? Okay, that's called texture. All right, I'm not going to sit here and watch you people struggle, but we should be able to do better than this. All right. All physical properties and I'm even going to say only right here. Only physical properties can be intensive or extensive, which is why I was trying to create a list. Now, intensive means it does not depend on size or amount. extensive means it does depend on size or amount. So we want to go back to the list y'all tried to make and figure out if those properties are intensive or extensive. Okay? All right, is everybody caught up? Yes, no? All right, so if we go back to the list. All right, if I say what the desk is made of, okay, I cut it into 3 sections. I keep a section, I send a third to Ms. Bowers and a third to Ms. Wicker's classroom. So I only have a third left. Will it still be made of the same thing?
Yes.
So that's an intensive property. Okay, it does not depend on size or amount. It's still going to be made of the same thing if I only have a little piece left. Okay, will its shape be the same?
No.
That's extensive. Will its length be the same? That's extensive. Will its width be the same? Will its height be the same? Will its weight be the same? Will its mass be the same? All of your measurement kind of things are not going to be the same if you cut it up and keep a third, send a third away, and send another third away. Will its color stay the same?
Yes.
Yes, that's intensive. Will its texture stay the same?
Yes.
Yes, that's intensive. Now, I'm going to add one. Density. Because y'all all got this wrong on the lab. Okay? Elijah came the closest. He answered the first question right, and then didn't get the final piece right. Were the 2 pieces of wood the same density? Were they?
Yes, because it's the same material.
That is the correct answer. Okay? If you look at your orange sheet, the densities are listed on the orange sheet. Are those densities measured at a particular size? No. That is the density of the material. Whether you have a 5 milliliter sample, a 20 milliliter sample, a 5 gallon, a 5 liter sample. That is the density of the material. The density doesn't change. It's intensive. Okay? Material has that density. The reason that it changed, and Elijah said it right, is they've just been knocked around and beat up over the last 10 years. Okay? But y'all have a lot of you had 0.5 something. 0.5 and then some numbers. 0.5 and some numbers. Y'all all had 0.5 something. The vast majority of you, some of you had some really jacked up numbers, but the vast majority of you had 0.5. Okay? Now, chemical properties. All right, these properties will alter the identity of a material. Now, these we cannot list nearly the same number of, okay? But they will alter the identity. some of these you guys are very familiar with. All right. For example, if I was to use the word oxidation, let me say this, the ability to oxidize. Somebody tell me what that is. Yep. All right. Oxidize is just rusting. All right. The ability to decompose. Anybody got a compost pile outside to let stuff decompose? Okay. A lot of people do these days. All right. My husband wanted to do it, and I looked at him like he was nuts. I probably should let him do it, but I was like, all right. Flammability. Okay. All of those are going to be chemical properties. Now, again, if I go back one slide, and I'll come right back. Are we going to label these as intensive and extensive based on what I put on that very top in red? Only physical properties are intensive and extensive. So we're not coming back here and labeling those as intensive and extensive because they're not. Okay? Oops. All right, everybody with me? All right. This is the first part or the first half of your lab. It's on properties. The second half of the lab is on physical and chemical change. Everybody got it? All right. All right, so physical change, again, will not alter the identity. And you will not get a new material. Oops. All right, it will not alter the identity, and you will not get a new material. Okay? So, things that you might remember from an earlier science class that you probably talked about are things like tear, cut, grind. What other verbs might y'all have used for physical change besides tear, cut, grind? Huh? I didn't hear you.
Rip.
Yeah, rip. All right. Now, some that are not as obvious for folks is phase changes or state changes fit here. So, can anybody tell me what the state changes are that you're supposed to remember from another science class? Okay, freezing is the word I wanted. Okay, freezing. What's the opposite of freezing? There you go. Freezing and melting are opposites. All right, so now let's go to the ones you did yell out. All right, evaporating. What's the opposite of evaporating? What, I heard it. Condensation. All right, boiling is certainly just fine. So let me put it up here. All right, those are fine. Does anybody remember a phase change that starts with an S? We will learn it, but if you haven't learned it, it's fine. It's not even part of the physical science curriculum, so I don't teach it. I only teach it in chemistry. What did you say, Elena? I didn't hear you. All right, it would be called sublimation. If anybody knows it. If you don't, it's okay. I'm going to teach that one later in the semester. But freezing, melting, evaporating, condensation, and boiling, I'm sort of assuming we already know those. Am I assuming correctly or no?
Yes.
Anybody not okay with those? If you are, just tell me. All right, freezing, we would start at what and go to what? Freezing starts as a liquid and changes to a solid. So melting would start as a solid and go to a, all right, evaporating starts as a liquid and goes to a gas. Condensation starts as a and goes to a, and boiling is the same. I wrote it under evaporating for a reason because it starts as a liquid and goes to a gas. Sublimation, I was just checking, but it starts as a solid and goes directly to a gas. And I will teach that one down the road if you don't know that one. Okay? Now, the biggest one that's hard for people to get straight in their mind with physical change is dissolving is a physical change. They always want to put dissolving in chemical, but it's not. For example, if you make Kool-Aid, you guys know sugar tastes how? Sweet. If you dissolve it, it still tastes how? Sweet. It didn't get new properties. It's the same property it's always been. Okay? Now, how are we going to know if it's a physical or chemical change? Most people can look at that list all day long and they're like, I don't know any more than I did a minute ago, Miss Wall. It still confuses me. So, I like to teach chemical change because there's 5 things I can teach you to look for. And if you don't see one of these 5, it's not a chemical change. First of all, a chemical change will alter the identity. And you will get a new material with all new properties. Okay, so that's the biggest difference. You're going to get a new material and it's going to have all new properties. Now, can somebody tell me what NaCl is? It's salt, okay? Just plain old table salt. Show me what it looks like. Okay, it's a white, granular, okay, it's a solid. I mean, we can shake it out of a shaker. It is safe to eat. Okay, would anybody disagree with those things that I wrote down about it? Okay, it's white, it's granular, it is a solid, safe to eat. Now, you can't eat a salt shaker every day for 25 years and not have health problems. But if you want to sprinkle some on your lunch today, you're not going to die from eating it. Now, I point that out because of what it comes from. Okay? Sodium is a silver metal that explodes in water. Your saliva is primarily water. So if you were to eat sodium metal, your head would blow off. Okay? Chlorine is a yellow, poisonous gas. Just a little bit, not a lot, but a little bit would kill us all. Now, combine the two, and it makes a perfectly stable compound that we can eat, sprinkle on our food, and most of us have in the house, probably somewhere in the kitchen, or we can sprinkle it on food when we cook, when we eat, and it's perfectly healthy for us. Okay? In limited quantities. Now, how do we know that it underwent a physical or a chemical change and not a physical change? There are 5 things we can look for. Any of these 5 things happen, then we know it's a chemical change. If none of these 5 things happen, it has to be a what kind of change? It has to be physical. That's what the lab we're going to do tomorrow is going to be on. All right. I knew when I put it up there, it was a pipe dream. Everybody got it? All right. So what are the 5 things? Number 1, 5 indicators of chemical change. Number 1, production of light. In the equation that I just gave you, when sodium metal reacts with chlorine gas, it produces light. That's how you know that one is a chemical change. Makes bright white light. So if you want to, you could write produce light there. Because that's how you know that one's going to be a chemical change. That one produces light. All right, number 2, the production of a gas. Now, how are you going to know that you made a gas in lab? Most gases don't smell. Some do, but most don't. Put a baby in a bathtub. How do you know he has gas? Bubbles. All right, number 3. Change in color. Now, I have to preface this by saying it has to be an unexpected change in color. Now, when I say unexpected, and I ask a question like leaves changing color, people go, oh, we expect the leaves to change color, Miss Wall. That happens every year. That's a chemical change also because the chlorophyll dies off in the plants, and that undergoes a chemical change I learned about last year in biology. Don't ask me to explain that. I've not had biology since 1989, so I certainly do not remember the process. All right. However, suppose you buy grape Kool-Aid and you go home and put it in water. That's grape purple food dye. That is going to turn purple. You know that. That is not a chemical change. Okay. Now, if you go home and make Kool-Aid that you expect to turn red, that again is not a chemical change. But let's say you mix 2 clear liquids in here, and it turns hot pink. Are 2 clear liquids supposed to turn hot pink? That's a chemical change. Okay? Number 4. Change in temperature. Now, change in temperature, again, is not putting it in the refrigerator or heating it on the stove. You mix 2 things and it changes temperature. So, probably in one of your science classes, you talked about these 2 words, endothermic and exothermic. Okay, endothermic means that heat is absorbed. Endo means what? Endo means what? Inside? Learn the prefixes somewhere else? Am I crazy? Y'all gonna learn prefixes? Okay, endo means inside, so heat is absorbed. This one is going to feel cold. All right, exothermic means heat is released and it will feel hot. Now, in order to tell if there's a temperature change tomorrow, you're going to have to feel the baggie, you're going to have to feel the test tube. Okay, nothing I've given you is going to injure you or hurt you, burn you, freeze your hands, anything like that. But you are going to have to feel it to see if it got hot or cold. All right. And the last one, number 5, is the formation of a precipitate. formation of a precipitate. This is a new vocabulary word for us. A precipitate in chemistry class is not rain, sleet, snow, or ice. A precipitate is a solid. Okay? A precipitate is a solid formed from two liquids. Okay? A solid formed from two liquids. Eventually, I will alter that slightly so that it says two aqueous solutions, but we don't know what two aqueous solutions mean yet. Okay? So, you have to have one of those five in order for us to have a chemical change. So, when you make Kool-Aid at home and you dissolve the sugar in the Kool-Aid, and you're like, is that a physical or chemical change? Run through the five. Do we produce light? You see light glowing from the Kool-Aid container. No. Do you produce a gas? Do you get bubbles bubbling up? Hope not. Did you see an unexpected color change? If you made strawberry Kool-Aid, it better turn what color? I hope. Did you change temperature? When you mixed it, did it suddenly get really hot?
No.
No. And did it make a solid because you mixed two liquids together?
No.
No. Then you did not have a chemical change. That's a physical change every day of the week. Okay? One of those five has to happen. You might have two, but you have to have a minimum of one. Okay? Now, we're going to practice. Not for very long before I have to assign homework. There's that. There it is. All right, on the front side, there's a chart. I just want you to put a check mark on what you think is physical and what you think is chemical, since you couldn't make me a list of physical and chemical properties. I know that's, we're going to go over this first side before we leave. The back side's going to be homework. All right, can you get that for Jocelyn? I'm just throwing it at her today. That's because she had to get dress coded this morning, so I'm ill. What'd you have on? You got on jeans. Yeah. Apparently you need to be denied. Took me a moment. And wear shorts under yours. All right, so on the front, put a check under physical or chemical, whichever one you think it is. Because we're going over that side. It shouldn't take us but about 2 minutes. Put a check. Are we done? All right, so if we look at number one, blue color, what'd you pick? Physical, density, good, flammability, chemical, solubility. What's that mean, first of all? To dissolve. Okay, so if it can dissolve, it's what? Yeah. All right, so that's physical. It reacts with an acid to form hydrogen. That's chemical. Supports combustion. That's chemical. Sour taste. That's physical. Some things just taste sour. All right, melting point. That's physical. All right, reacts with water to form a gas. See how it says reacts? Reacts will make it chemical. All right, reacts with a base to form water. Chemical. Hardness. That's physical. Some things are harder, some things are softer. If you were in earth science, maybe you talked about the Mohs scale and the hardness of rocks. Some metals are hard, some are soft, like titanium is very hard. Lead is very soft. Boiling point, physical. Can neutralize a base, chemical. Luster is what? Is physical. What does it mean? Shiny. Very good, Michaela. And odor. That's physical. Some things just have a natural odor that stinks, and some things have a pleasant odor. Now, on the back, let me tell you what you're going to do for homework. Now, you're going to label physical or chemical just like you did on the front, but I want you to do one other thing. If you tell me it's chemical, you have to tell me which of those 5 indicators. And you don't have to write the whole indicator. You can write heat, you can write temperature change, you can write T and change. If you say it's precipitate, write precipitate. But tell me which of the 5 indicators you said it was. Because if you can't tell me which indicator, is it a chemical change? No. Okay? And then tomorrow we'll go over this. We'll do the lab and we'll review a little bit for the test, which is Wednesday. And then we might even move on some. Yep, the test is Wednesday. Tomorrow, didn't I just say that? Do you listen to me?